So hello everyone, thank you for the opportunity actually to be here. I'm Mario Acosta, coming from Barcelona Supercomputing Center, in particular about from the Earth Sciences Department. And today I would like to share with you a little bit more about how we can relate HPC and the specific topics, the specific field in which we are working at BSc in our department, but also for actually all the weather and climate community. So I'm coming, as I said, and this. In our case, we try to focus in climate and also in air quality. We have different groups. In my case, I'm coming from the computational air science. We are close now to 170 people, and we have great implication in different horizon programs, Copernicus. Also, we are participating in the Destination Earth initiative to create this digital twin about the Earth system with the climate scenario and prediction. About the specific topic that I would like to share with you is the relation between this HPC and the supercomputer. Well, in my case, I'm user from MarenostrumV, but also the other PresaScale machine, and the topic in which our scientists are working, ocean and climate modeling. And the point to try to understand a little bit and provide some context about this, to try to create these, for example, scenarios to evaluate or to study the climate change, for example, for making decisions for the government, to try to do an evaluation for the next 20 years. The point is that in the last year, we have improved the accuracy of this climate model. So in this case, we started in the 60s, 70s, simulating the ocean and the atmosphere, but in the last year, we have included more and more components which have a very high computational cost. So in this case, we started with the ice, we included also the biochemistry and different components with the different equation that is increasing this computational cost of the model. Then also we are talking about chaotic models. So in this case, the equations that we are using are non-linear, and this means that the result can change a lot from one run to another one. So what we are doing actually is run an ensemble to create a statistical spread and try to evaluate that the average of this result at the end are correct. But this means also that we have to repeat and again one time, another time, the same simulation to make possible to have this accuracy with the model. And finally also, forecast, usually maybe the simulation is around 10 days, but the simulation that we are doing, the prediction plus projection, we are talking about 100 years simulating, using the typical time stepping, the same model, which means very long simulation in our supercomputer, in MarenostrumV, for example. So with the complexity, with this repeat the same simulation several times, and then also this long simulation is producing a complexity in our model, a computational cost that is impossible without the real supercomputer. And the final one is the resolution, which is also very important for us. So we have increasing the resolution of our model. Now we are our global model, so is to simulate the complete Earth during the last years. And now with some initiative of ESiWACE or Destination Earth, we are going to 5 kilometers for all the Earth. To make this possible, this is, by the way, NEMO model, which is an ocean model on LUMI supercomputer. To make possible this specific simulation, which is a climate prediction for the next 20 years, and this is ocean temperature, the need for this increase of the resolution improve the accuracy of this motion about this current that we can see here, but also is increasing a lot, again, the computational cost. So in this case, we are talking about 16 times at the moment that we are increasing this of our model. The results for the accuracy is impressive, but at the same time, we are also taking more and more computational power from this model in which we are working. And the final one is also something that we discovered, no? And where HPC is also very important. We are not working just for scientifics. So in this case, we are producing a lot of data, as the video that you were seeing before. But we also discovered that all this information is difficult to analyze, is difficult to use when we are talking about people different to the scientific community that we usually work. But at the moment that you move for general user or just for example, a government, we have to improve also some environmental services in which we are working, using streaming, using clouding, to make possible with HPC that we move all this information that we are producing now to the general user and make possible to use different applications with this co-production and co-design to put all this data in a format that everyone should be able to use it. So this is the context. And the point, if we need more computational power, in this case, is because it's critical for the earth sciences model. So we cannot just stop in the specific model that we were using, for example, 10 years ago. So we are moving this complexity, long simulation, the resolution, and obviously, as I said before, this is going to need more and more resources. The climate model are a typical one, in this computational fluid dynamics. So in this case, we are using domain decomposition, we are using some communication between the different subdomains, and this means parallelization, and try to use a new supercomputer with more resources to make this possible. But at the same time also, as is happening with other fields, earth science models are very complex. So it's not just to move to a new supercomputer with more resources, we have to work in the efficiency, in this computational efficiency of our models, and try to ensure that always we are exploiting the new hardware, the new technologies in an efficient way to ensure, with this optimization, that we are moving to the new generation. In the hybrid era, that was the previous supercomputer using CPUs and GPUs, this was more or less, we could say easier than before. But now we are moving to this ESiWACE era. We are now with the PreSSK machine, the HPC machine, LUMI, MarenostrumV, and Leonardo. And as you know, this kind of machine in the future is going to be more purpose-built, which means that the adaptation to the new technologies is not only to improve the parallelization of this domain decomposition that we were using in our model. Now we have to work in heterogeneous computing, try to evaluate that we are working with new fixed accelerator, and try to adapt our problems, in this case, these climate models, to the new generation. And of course, what we can gain is clear, new computing elements, more parallels, data streaming, as I said before, to spread the information that we are producing. And also we can gain to ensure that we can follow with this improvement of the complexity of our model or larger data set, But there are three specific issues that we have to take into account for this adaptation to PreSSK and ESiWACE path for the climate and weather models, which is, it's clear, modeling and simulation, machine learning, and big data analytics. In my case, the background in which we are working in my group is more related with the modeling and simulation. And here is where we are working in different projects to ensure that we are doing this adaptation for the new machines and the new technology. In short time, we are working to do this integration and adaptation to the new Euro HPC machines. So we are working specifically to make possible the new model with the new computational power in these machines. And then also we have this initiative, which is the Center of Excellence that I'm going to summarize in this presentation in the next slides. And also the digital twins, which actually now is a very ambitious initiative in which we are working and is going to produce these results for climate prediction impossible until now. In the future, also is important the adaptation to the new RISC-V, quantum, or just FPGAs, clouding, or just also adaptation for the new machine learning model, removing a little bit this discretization of our model and try to adapt for new statistical methods. So as I said before, these are the specific flagship projects in which we are working now in weather and climate. Not only from BSc or my group, actually this is for all the European community, the Euro HPC. These one are for these digital twins for the complete Earth and then also for the ocean. And what we're going to introduce here is ESiWACE. ESiWACE is the center of excellence to achieve this excellence in exact scale for the weather and climate models. I am the coordinator of this project, but involved there are several partners from all the Europe, apart from BSC. We are starting this project in 2023 and remains almost 3 years more in which we are working for the improvement of this climate model and the adaptation for the new pressure scale machines. As you can see here, there is an example using one of the models, evaluating the differences when you are improving this resolution and the possibilities in the ocean velocity motion when you are gaining this specific resolution. For this project, we have this high-performance computing from 3 different supercomputing centers, but we have also different hardware vendors, for example, with Acosta or Biden, or just other institutions which were working with the expertise in weather and climate. The 3 top levels of this ESiWACE project is the first one is clear according to the context that I was explaining before, which is make possible this efficiency of the climate and weather model. So we are working to improve the efficiency, to gain this adaptation to the new pressure scale machine. But also it's super important to work in new tools, which is going to make possible this adaptation. So in this case, we are working in different tools for example, for the integration with accelerator with domain-specific languages, some tools which is going to reduce the precision of our model from double to single precision, as also we are seeing in other fields. And something that is also super important now is serve as a sustainable community hub. So in this case, we try to also be with the community and organize different training, communication, workshop, dissemination activities to ensure that all the community is working together with also all this improvement in the model that in which we are working, or also they know about the specific tools in which we are working. To make this possible, and I'm going to enter in detail in this, just to mention that we have different work packages in which all the institutions are working together. As I said before, for example, in the technical improvement for the adaptation to the RISC-V, or some co-design also with the new AMD machines. Then also developing these community tools. We were talking before about this reduce of the precision of the variable, or just data compression, because we are producing petabytes of data with all the new simulation, and we have to ensure that the post-processing and the compression of the data is something affordable to store and to try to produce the final result for the general community. And then also we have a complete pillar just for the services, the training and the networking with the community. So in this case, we are organizing workshop, hackathon, trainings, and everything is free for the general users. So just you can apply for this, taking into account this weather and climate topic for HPC, and just join to the community and the different events in which we are working. And something that is important because it's also free and we try to provide for the general uses is our HPC services. So in this case, we are working with the different experts that we have in our consortium to provide these specific services for all the community. So we have open calls and not only the weather and climate institution or centers, but everyone from the European community, from the Euro HPC community can apply for this and receive some services in containerization with the application in which they are working, data compression, or just, for example, optimizing the weather and climate model in which they are working. We have also available a service portfolio in our webpage, which is summarizing all the HPC services, training, dissemination, and all the things in which we are working. As an example about the specific services that we are offering to the community, this is the first round in which we have been working. In general, this kind of services that we are providing is, for example, the adaptation and the porting for GPUs, one model that is working in the CPU, we are porting it to the GPUs. but also general optimization for, profiling analysis and try to do some optimization for the CPU part, profiling, the MPI communication, improve also the input-output of the model using asynchronous communication and I/O servers, or just, as I said before, the reduction of the precision. There are more applications which we are going to start to work now, and in general, I think that something that all the community is requiring is the GPU porting, because now with the new machine, it's important to move from the CPU to the GPU. So we are working a lot in this GPU porting for different applications. Plus, for example, for one of the most important European model, now also we are going to work in this reduce of the precision of the atmospherical part. And the other service, as I was talking before, is just provide the tools. So the first one, there is HPC expert working together with the owner of the model, but also we offer just the tools. So in this case, for example, if you want to explore for a climate model this tool to reduce the precision, you can just take it with the service tool. We provide everything free, and you can work on this, and you receive also some support to understand how is working the tool, or just to evaluate how to use everything. These HPC services are going to be open during the next 3 years. So there is some course now, but actually we are going to be continuously open this course for the next one. Then also, as I said before, we have some training, again, open for all the community. We are offering hybrid sessions, so it could be physical or hybrids in this case, and everything is free. Now we are moving to a new hackathon, which is in October, and it's trying to exploit the LUMI supercomputer in an efficient way for the application in which you could be working now. We have also a training calendar where you can check all the events that is going to be there in the next 3 years, plus also other projects. In this case, other COEs, Center of Excellencies, or other Horizon projects are also included in this calendar, so you can check everything. And we are also offering online training courses. So in this case, it's not for a specific date, but you can go there, download the specific training, and just evaluate if this is something useful for you. There is now this hackathon in Finland. Now is open. Everyone can apply and try to also understand more about this adaptation in which we are working. Then also it's important from us the community engagement. So we have different social media that you can evaluate, and you can check a little bit about the work in which we are working for this HPC adaptation for weather and climate model. There is several dissemination activities, paper, research work in which we are working that you can check in our community and just try to evaluate more about what we are doing. And also we have different workshops, conferences, just events that you can explore. Also we have now open for the next one in Lecce, now in May. It's just open at least for the virtual session. So again, you can check a little bit about the different sessions in which you are working, and if you want, you can join us. And that's all from my side. So this is like a summary about what is this Center of Excellence. So the point is that we are working in the improvement of all the weather and climate communities, at the same time that we are developing different tools, working with the community in training, hackathon, workshop, and all this stuff, while also we are involving with all the Euro HPC, all this infrastructure, and we could say that the hardware community, different scientific projects, and moving to the future for this new flagship project at Decisionaire, Edito, and try to involve also in new projects related with weather and climate. And that's all from my side. So thank you. I don't know if someone has any question.
Thanks for the presentation, Mario. What is your opinion of this beginning of the project with the usage of Euro HPC pre-exascale machines from a user point of view to run this simulation?
But my opinion about what?
About the usability. How is your experience? Can you comment on how did it went?
Yeah. Well, actually, as you know, we are really close to the user working in this Euro HPC machine. Our experience until now, MarenostrumV is just starting. Leonardo also was starting some months ago, and LUMI remain like the first one some months, almost a year, I think, no? And the experience until now is that we need to support, we need to work with the community because the machines are yet starting to work and it's difficult just right now. For example, in LUMI, they are experiencing maintaining every two months, for example. And well, we have to work with the community because the queues are terrible. So it's just to be there with them and try to do as much as we can. But just right now, it's like this machine is starting and we have to go with the community to improve this way.
Any other question? I have one. So I'm also participating in a Center of Excellence, and we have this fantastic review at February, I think it was. And one of the questions that they make to us is what we are doing as a Center of Excellence to return the investment to the population, to the community. What is ESiWACE doing for that?
So I think that the easy reply here is that we are helping to the climate and weather model centers. It's just a scientific result, we could say. But the point is that we have to take into account this climate adaptation in the future. So what we are trying to do now is with this adaptation and try to gain this more computational power with the machine, is this making decision for the government. So it's not the general user at the end, but helping to this government, no, with the model in which we are working for the Climate and Weather Center, we expect to everyone, no, at least to receive all this information that we are producing in a way that they can understand it, for example, to understand what is happening in the climate change in the next year. And this is something we are trying to push a lot for the future.
Any other question from the audience? So if not, let's turn to the speaker.
Thank you.